Okay, today we're going to look at solving quadratic equations. Quadratic equations are in the form of ax squared plus bx plus c equals 0, in which a, b, and c are all numbers. When we look at these problems, we can think about what factors out of the problem if they're not squares. 3 and 21 are not perfect squares, so we can think about the fact that 3 factors out and we're left with x plus 7. X squared and 16 are both squares, so this is a difference of squares. If we'll think back, we can remember that a difference of squares means that we're going to multiply the conjugates of those squares. Let's look at the next one. 5 and 40 are not perfect squares, but we can take 5 out of, we can actually take 5x out of this, and we're left with x minus 8. The next one, we can factor, we would actually have to come up with our factors of 90. We have that will equal 1. We can have a pretend 1 here. And we want this to multiply to be negative 90, but add to be positive 1. We have 10 and 9. If we add a positive 10 and a negative 9, that will give us 1. So we're going to break this up into x plus 10 plus 10x minus 9x minus 90. That's x squared. And then we can break that into x squared, and we end up with, we can take x out of here. We end up with x plus 10. And then out of the second set, we can take negative 9 out, and we end up with x plus 10 again. We have the same inside the parentheses. So we have x minus 9 times x plus 10, and that's a factored problem. Let's go ahead and move on to the next one. Okay, let's now look at solving specifically quadratic equations, where it's x squared, a number x, and a number. They're linear equations with first degree equations, and the variable is the only one with the first power. Quadratic equations are second degree equations, meaning we have an x to the second power. Okay, so as we can see, a quadratic equation is an equation of the second degree. Its standard form is ax squared plus bx plus c equals 0. A, b, and c are real numbers and do not equal 0. The zero product is where we know that if x times y equals 0, then either x or y has to equal 0, and maybe both of them equal 0. And we'll use that property to solve quadratic equations. So we know that if p times q equals 0, then p or q will have to equal 0. Let's look at our first example here. We have solve x minus 5, x plus 2 equals 0. So what we're going to do, we could have more than one solution. We're going to go with x minus 5 equals 0. We're going to solve for x. And then we're going to try x plus 2 equals 0, and we're going to solve for x again. So here we see that x could equal 5 or negative 2. It could be either one in this particular problem. Okay, now before you try to solve quadratic equations, though, a lot of times you have to actually factor them out so that you have the two problems like we just saw. So let's look at this next example. This is not set up where we can say something equals 0 or something equals 0. So let's go ahead and factor it out. We have x plus 2 and x plus 6. So we're going to say x plus 2 equals 0 or x plus 6 equals 0. When we actually solve that, we come up with -2 or -6. So either of those could be solutions, but we need to go ahead and plug them in to see if they are solutions. So on here we have a square of x and we have a 16, which is a perfect square, equals 0. So let's go ahead and factor out our 8x, and now we have 8x times x minus 2. So we still have a multiplication problem here. If this problem equals 0, then we know that either 8x has to equal 0 or x minus 2 has to equal 0. So therefore, x is going to equal either 0 or 2, and we have to plug those two numbers in to see which one works. So whenever you're solving a quadratic equation, your first step is to write it in standard form, which is ax squared plus bx plus c equals 0. You're going to factor the polynomial and then set each factor to equal 0 so that you can use your zero product property to solve. And then you want to check your solution with the original equation. Let's look at another example. Here's another example, 2x squared minus 8x plus 8x minus 42 equals 0. We know how to factor these problems, so we're going to go ahead and factor the problem. And we're factoring out our 2, and then we can factor from there. We have x plus 7, x minus 3. So now we have three things that we're actually multiplying together to equal 0. Now in our rule, our original rule, it says that a cannot equal 0. So we know that 2 does not equal 0, but x plus 7 may equal 0 or x minus 3 might equal 0. So we go ahead and solve for, and x is either going to equal -7 or 3, and we need to check that to figure out which answer it is. Let's look at one more problem, one more example here. We have 3x squared equals 147. So what we're going to do is we're going to go ahead and put it in standard form so that it's all on one side of the equal sign and then it equals 0. And then we're going to factor it out. Notice here that we're now left with a difference of squares. So that means we're going to multiply the conjugates. And that leaves us with 3 cannot equal 0, x minus 7 may equal 0, or x plus 7 equals 0. And we're going to solve that and check.